Okay, hello everyone, and very warm welcome. I see people are joining the webinar room, and we are going to get started in about a few minutes to give a time for everyone login. As you join, please feel free to open the chat box, and we would like to know where you are all attending from today. Please type your city, country, maybe your organization, so we can know each other before starting the webinar. Okay, let's see if there are anyone who writes where they are attending from. CA Malaysia. Hello, welcome. Malaysia, we worked for CA Malaysia before for ITOT project, and we have been in Kuala Lumpur. Wonderful. And Kenya, Benson from Kenya, welcome. And another attendee, Bob from Kenya again. We have CA Lebanon. Gambia, Civil Aviation Authority, CA Nigeria, CA Fiji, welcome all of you, wonderful. It's very great to see all of you. Bosnia and Herzegovina, Sarajevo International Airport, welcome. Riyadh, Saudi Arabia, Singapore, Monaco, South Africa, Nigeria. Okay, fantastic. We have truly global audience today. So, okay, all right. It's almost 3 past 11 here in Turkey, and let's officially begin. Good morning, good afternoon, and good evening to everyone. Thank you for joining our webinar titled ICAO's New OES-OFS Concept Case Study for Changes. My name is Halil Uğracan, and I am an aviation safety specialist and team leader here at Haritaevi Aviation, and I will be your host for today's session. We are here to discuss one of the most critical changes to the aerodrome safeguarding in decades. As many of you know, ICAO's Amendment 18 to Annex 14 became effective on August 2025, and this is crucial because it sets a firm deadline. By November 2013, all international aerodromes must complete their transition and apply this new OLS concept. In this time, we have exact 5 years, but this transition requires very careful planning, new data, and new assessment methods. I have already seen from the registration forms that more than 85% of our attendees are officials and specialists from civil aviation authorities, air navigation service providers, and airport authorities from all over the world. We were expecting this high level of interest as the topic is very core of your operations and important for future planning. And because you are the key stakeholders in this transition, we want to make a special offer for you. If you are joining us today from CAA, ANSP, or Airport Authority, please send us an email after this webinar. We would be happy to arrange a private workshop just for your organization, and we can work directly with you to analyze your specific aerodromes and build transition plan for this new concept. Okay, and now get to our main presentation. This is my great pleasure to introduce our presenter, Dudu Erol. Dudu is an aviation safety specialist at Haritaevi Aviation, and she holds a Master of Science degree in City and Regional Planning and has been leading our technical case studies on this exact transition. You can write your questions during the webinar, and we will have question and answer session at the end of the presentation. I wish all of you a beneficial webinar. Dudu, the floor is all yours. Thank you.
Thank you, Mr. Ali. Hello, everyone. Hope everyone is doing well. Today, we will start with a brief theoretical overview of new ICAO's new obstacle limitation surface concept, and then we will move on by examination of 3D surface drawings in Google Earth for better understanding. And as I see from the survey, nearly half of the participants are familiar with the new concepts. Actually, that's good. And why 1/3 have a basic awareness of it? Of course, there are experts also. And I hope it will be an enjoyable session for everyone. And if you have any question or comment or recommendation, please write into the chat. And also you can feel free to contact later via email. Let's start. First, we will talk about why change is needed and new OES concepts, aims and goals, and what is change, and then move on to the summary detail about the new concepts, new introduced airplane design group, obstacle-free surface, obstacle evolution surfaces, and then on the next part, we will move on with the effects on airspace protection, how the surfaces change and how affect the obstacles and the other settlements objects around airports. And then as final part, we will move on with case study from Kenya and Qatar and Esenboa. And we will see in this case study is Google Earth in 3D format with some comparison with old OES concept and the new concepts. Okay, let's start first with why was change needed. And as most of us know, urbanization increasing day by day after the industrialization and with the technology, of course, especially in vertical urbanizations increase, and this situation creates pressure around the airports, and this is unavoidable, and managing both flight operations safely and to meet need for new urbanization in the most efficient way becoming is difficult with current OES concept. And ICAO surfaces old OES because it's published in August, and I will tell old OES and the current new OES. ICAO old surfaces, which developed before 1950s, is strictly limited around airport surroundings, and sometimes it may be unnecessary, or sometimes it will be inefficient, sometimes it's too protective, sometimes less protective. It is kind of like same shoes for all feet. It is not good and efficient way actually. And also as well as aircraft technology is changing and the surfaces also remain same. This situation brings some negative outputs. And I will explain these negative outputs very briefly. And current obstacle limitation surface are not aligned with actual flight paths, and this cause may leave the critical airspace unprotected, or sometimes also these surfaces, old surfaces, cause over-restrict, especially the non-critical zones. And also the modern aircraft have different performance needs due to the increasing technology and changing technology, and current obstacle limitation surface does not reflect diverse aircraft performance properly and in an efficient way actually. And another problem is with the old obstacle limitation surface still in same and not enhancing or adapt to new developments. And also it's not addressing the capabilities of modern aircrafts, and it's not meet with the needs of the urbanization standards, increasing of the population, unfortunately push up to cities, expand through the sometimes airports, and it is not reflecting procedure-based operations, and uses actually cookie cutter model surfaces regardless of aerodrome characteristics of course. And as a final examples why change is needed, and as I said on the previous slides, it follows uniform one-dimensional approach for all airports, regardless the traffic type, frequency of the airport, or terrain of the airports. surroundings, and this sometimes leads to excessive restrictions or inadequate protection in some scenarios. And I will show the example from Esambra Airport at the end of the slides about this inadequate protection scenarios. And new concepts brings us rather than cookie cutter model, new concepts propose a modular, adaptable framework which is tailored to specific site conditions. With new model, you can create different surfaces which is most efficient way according to characteristic of the aerodrome and its surroundings and characteristics. And one of the most important changes is in Annex 14, for example, ARC does not take into the account aircraft size and speed on end. In current surfaces is taken into the account like FANZOP's requirements. And also another problem is actually when a structure penetrates or object penetrates the old obstacle limitation surface, a systematic analysis is required to answer the question, what is the impact of the flight operations? Sometimes most of the objects that penetrate surface is not have a significant effect to the flight operations. This is not clear and needs sometimes more detailed analysis. With new surfaces is we will know if some of the object penetrates the surface, this has a problem and this has negative effect to the flight operations, and aeronautical study must be done for this object. Okay, let's move on with the aims and goals. New concept is procedure-centric design, mostly taken into the consideration of especially obstacle evaluation surface into the concept surfaces and actual flight paths and aircraft trajectories. And also it's evaluate obstacle that pose measurable risk to operations, and if the obstacle have effect or have a penetration to those new surfaces, it need a risk-based assessment. And new surface also the most important thing, has a dynamic and flexible geometry. It can be changed according to the different airports, and also the adaptable surfaces can be adaptable according to some different trajectories around the operation type and aircraft performance or the flight procedure designs. Sorry. Yes. And the aims and goals, first is protect the airspace only for necessary existing and intended aircraft operations, and then differentiate obstacle requirements according to the effect of obstacles on operations, and then also protect existing instrument operations at aerodromes, and provide more clear and risk-based guidance for aeronautical studies, provide more safety for operations, and increase accessibility. And airspace protection is now more efficient. And now we can move on with the changes. And we will talk about in this part, what is change actually, and what was in the old obstacle limitation surface has, and with new concept, what is remained or what is now not existing. We will see during this part actually. Sorry. Actually, three main changes is come up with these new surfaces. One is almost all of our, I can say, no, the current obstacle limitation surface standards taken to the account while deciding the design parameters use current runway code, runway number code from 1 to the 4. And in these new concepts, Instead of runway code, it actually provides the aircraft wingspans and aircraft actually performance like consoles. So criteria, and also obstacle-free zone is changed. Obstacle-free zone in old scenario, obstacle-free zone is applicable for only Cat2 and Cat3. Now obstacle-free zone, most of the obstacle-free surfaces. I will give the remark in here, not direct equivalent to obstacle-free zone. Of course, I will explain it in the following slide. And obstacle-free zone surfaces, inner approach, transition, and bulk landing surfaces now introduce also what non-precision and non-smooth approach actually. Sorry. And also there will be new surfaces which comes from concepts documents. We will see in the following slides. Actually, and all of these summarize us. New surfaces provide more clear guidance for need of analytical studies and by distinguish obstacle requirements based on how obstacle impact flight operations. And to provide these new concepts, integrate some of the concept surfaces into the new annex under surfaces. Mobile obstacle limitations as well as on-ground operations is more clear in new concepts. Also, the obstacle management is more important and also provide efficient way in terms of operational impact. One of the most important changes, as I said in the previous slide, runway code number and aeroplane design group. And in old version, actually, different aircraft has same surface because each aircraft has different performance level, but in old obstacle limitation surface parameters, design parameters has different surfaces. How can we say that? For example, in here, you can see code number 4 and number 2, how on the previous concept, how it changed now different parameters in aeroplane design group. Because aeroplane design group depend on the performance of aircraft, and also it's applicable for each runway individually, and also it taken to the consideration indicates the airspeed thresholds and as well as aircraft wingspan. And as you can see in here, for example, 2 aircraft with IRC runway code, DORC can be quite different in terms of aeroplane design group. For example, code 3 or 4 now is applicable for, as you can see in the table, to C3, 4, and 5. And it shows that actually aeroplane design groups allows for more accurate planning in terms of protection surfaces, and now is better operational risk assessment provide us. And we will conclude the webinar with the examples from Kenya and Qatar and also the Ankara Samba, showing how code 4 airports now have different surfaces under new concepts. We will see these differences in 3D with the surface geometry. Maybe it can be more clear at the end of the session. Another summarization about the change. There is a table in here, current obstacle limitation surface in annex 100, and is it changed or remained or not existing anymore shows, and also the new concepts, what is comes new. And as you can see here, approach, takeoff, and transitional surface changed. Actually, most of the surface, their slope is increased as instead of takeoff point surface. Approach slopes is increased, and theirs as length is decreased as new surfaces are more narrower there and now. Sorry, more narrower now, and also the design parameters is changed. And conical surface is not applicable anymore, and also the outer horizontal surface is not applicable. Inner horizontal change, but it is now wider and same named as horizontal surface, and also it's dynamic and variable according to aeroplane design group. I will show the examples again at the end of this presentation. And new concepts brings instrument departure surface is from concepts, and takeoff climb surface is now more accurate and meet with the different ICAO documents, because it can be some gaps between especially in takeoff climb in between ICAO documents, and obstacle-free surfaces is introduced, is alike approach and transition. It's alike coming together approach, transition, and obstacle-free zones. And as I said before, horizontal surfaces change, and another two new surfaces, surface for precision approach, surface straightening approaches are introduced with new concepts. The new concepts actually aims to deliver more targets, risk-aware, and operational relevant airspace protection framework, which provides balance in safety, capacity, and infrastructure development. And now, until now, we will talk about what is change, why change is needed, and I hope everything is clear now, until now. And if you have a question, please do not hesitate to write on chat part. Now, I will move on with some more detail about the new concepts. Okay, new concepts has three main changes and groups actually. First one is the new aeroplane design group, second one is obstacle-free surfaces, and the third one is obstacle elevation surfaces. New aeroplane design group actually provide consistency with the performance and size of the aircraft. And now I will move on with each part of these changes briefly, and outline the main objectives of these new initiatives, and then move on in details like OFS, much more like obstacle-free zone, approach and transition. And also I will talk about the OFS only for letter dimensions for approach surfaces. And also we will talk about one of the significant income of OFS. Actually, obstacle-free zones applicable, as I said at the beginning of the presentation, applicable for category Cat 2 and Cat 3s. Now it's new obstacle-free surfaces, inner surfaces like back landing, inner transition. Actually, back landing is not applicable. And inner approach, both is now applicable for operations instrument and non-instrument precisions and non-precisions airports. Again, as I said at the beginning, each of these surfaces must be designed according to each runway uniquely. And obstacle elevation surface is actually relied on obstacle clearance criteria, and more flexible and adaptable to local needs of and different operations of different airports. And actually these surfaces, as we see on the last presentation, here. See, most of the surface actually comes from concept surface, and it brings matching with the required volume of airspace in a more efficient way. As I said, all these needs changing is more bring us more flexible and adaptable surfaces according to local needs and different operations. And also, we will talk about it. All of these obstacle elevation surfaces is not applicable for now for all airports. Yes, obstacle limitation surface like approach to takeoff, transition, and inner horizontal, conical, outer horizontal is all are applicable for all type of airports. But in this new concepts, According to airport's environment, some of the surfaces is not applicable, some can be usable, and it brings more efficient way and also it provides the use only what I need to protect. Right. Maybe I can give the example about on non-instrument approaches, for example, no-need surface for straightening approaches or precision approaches. And also with new concepts, horizontal surface is not mandatory, but of course there is an optional way. It's applicable if circling is available actually. Let's move on with the aeroplane design group, and here you can see is the actually Annex 14 old obstacle limitation design parameters is used runway length and approach category while deciding their design parameters, surface geometry design parameters, and also there was some inconsistency between documents. And now airplane design group combine all this performance, aircraft performance and size of aircraft needs together, bring together, and two main things is important now is airspeed threshold and wingspan. Also the mass of the aircraft is important with new parameters. You can see in here 7 different groups is now applicable. And we can see that according to this new change, the shift from traditional obstacle limitation surface standards to aeroplane design group standards reflects a need modern and flexible and efficient airport design. And as I said, all these individual ADG should be identified for each runway, especially some of the airports has a different 2 or more runway. Such kind of these airports must be designed or identified for each airport according to their needs or the aircrafts which is operate at this runway actually. And also this ADG, while choosing this aircraft, it should be most demanding one, and also most large size you can choose. Let's move on with the obstacle-free surfaces. Obstacle-free surfaces has 5 surface introduced. Approach surface, it is much more like the old approach surface, but the actually this length of the inner edge is decreased and slope is increased and size is more narrower now according to ADG. And also according to runway width, also inner edge can be changed and adaptable. There was some more dynamic parameters while creating approach surface. Transitional surface, the design logic actually most the same. And also inner approach surface, the inner approach surface, slope is increased and size is narrowed now. Most of the surface size is now more compact, we can say. And for example, in inner approach surface, ADG4 has a, I can say, 185 meters inner edge, and ADG2B has 125 meter inner edge length actually. Again, inner transition surface, bulk landing surface introduced, inner approach, inner transition surface, also applicable non-precision approach. And while designing the approach surface, actually, dimensions and slopes depend on ADG, which you choose. And by the way, I want to add something in here. You can find aircraft parameters from ICAO Eurocontrol websites and to decide ADG and runway type. Dimensions and slopes depend on ADG and runway type in approach, and mostly, as I said before, smaller length and higher slope. And also the slope is a little change in transitional. According to, based on the runway type, instrument and non-instrument surfaces, instrument and non-instrument runways has a different parameters in new concepts. And slope is increased and length is fixed mostly. And also the total length is decreased for the approach surface from 15,000 to 4,500 for instrument runways, as of course for the non-instrument runways it's less than this 2,500 around something. I couldn't remember the exact numbers. For example, current obstacle limitation surface, non-instrument categories 1 and 2 slope is same, as well as same with new aeroplane design group 1 and 2A and 2B. There's no change with this. And I want to add some remarks. We can make also more deep changing, make addition to these surfaces, like according to approach angle is lower than 3 degrees, slope should be changed. These changes, which is unique to the procedures of the airport, now is applicable for while designing these surfaces actually. Let's move on with the obstacle-free surface inner part. This part is much more like obstacle-free zone, sorry. In all approaches, height is increased from 45 to 60. Obstacle-free surface, now as I said in a few times during the presentation, introduced for also Cat 1, non-precision instrument approaches. And also one of the main design parameters changing is the inner approach length increased. And also existing obstacle that penetrate approach and transition surfaces criteria is changed now. Before the old obstacle, new concepts, if the sum of the obstacles penetrates approach or transition, sometimes they need any aeronautical study. If there's no risk, they can be stayed. Now, with this obstacle-free surfaces, much more like obstacle-free zone, both inner and inner approach, bulk landing and inner transition, also approach and transition surfaces, if penetrates by any obstacle, that obstacle should be removed. And if it's not possible, then permitted with aeronautical study actually. I have a question in here. In Turkey, sometimes most of the objects that penetrate approach or transition is not taken into account and is not made any analysis about aeronautical study. I am not sure, each country has a different legislation, different rules. Maybe we can write to the chat about it. And also, let's move on with another part, obstacle evaluation surfaces. Actually, I want to show you the surfaces in 3D format. That's why I will try to make my presentation more quick and faster one. And as I said at the beginning, each aerodrome has a variable flight procedure. That's why obstacle evaluation surface now brings more changeable and adaptable surface according to the needs of the airports and their flight operations. And standard parameters has been set to cover the most common types of operations. On the other hand, these new parameters and new surface can be adopted and can be changeable or applicable or not according to operation type of the aircraft. Okay, here you can see takeoff climb surface, instrument departure surface, horizontal surface, surface for straight and instrument approach, surface for precision approach, introduced as an obstacle evaluation surface. I will show you the very brief information about surface again. And with instrument departure surface and takeoff climb surface, again, dimensions depend on airplane design group and aircraft mass is above 5,700 kilometers or not. And takeoff climb surface is much more like combination of annex 14 takeoff climb and takeoff annex 4 takeoff flight path area, because its length also decreased, but slope is same now. And instrument departure surface it comes from Hansov surface, and the dimensions same for all aeroplane design group is for the instrument departure surface. That's why there's no differentiate according to ADG. Horizontal surface is provide some protection for especially for terminal instrument flight procedure. Dimensions depend on ADG. As you can see, the color is not clear, but I will show you in the assembly example later at the end of the webinar. And as you can see, ADG1 and ADG2A is actually it's more wider according to inner horizontal, but ADG ADG1 and 2A has radius is more compact, less according to the current obstacle limitation surface, and 2B is and the others is more wider. 2B also wider than both combination of inner horizontal and conical surface. And of course, ADG2, C3, and 4, and 5 is much more wider area. And it's protects circling and visual maneuvering, and this surface is applicable is if there is any circling around the airport, or you can use also for protection, protect indirect return departure. And most of the one of the important change about this surface is much more like inner horizontal surface, but actually now is the, as I said, and as you can see in the picture, now is the radius is wider and also height is increased. Only 1 and 2A, ADG1 and 2A is the same height 45 with inner horizontal surface, and 2B is increased to 60 and the others increased to 90 until the 90s. And okay, good. State and instrument approach and surfaces for precision approach, another important approach for especially to protection for aircraft operations and provide efficiency about the aerodrome environment protection. Yes. And these surfaces protect most critical areas, IMP, war, and approaches, and also a special surface for precisions applicable only precision approach runways. And these surfaces include approach, missed approach, and transition components. We will see these surfaces in 3D format again. And sorry. It's consistent with a dimension of basic ILS surfaces, which is provided concepts again. And here you can see the more detailed picture of the precision approach surfaces. Again, in here, dimension standard for all aeroplane design group for this surface. Design principle is to consider obstacle which may have impact on obstacle minima, impact on minima of the precision approach. Let's move on. Okay, now we will move on very quickly about the new obstacle concept, how it affects the airspace protection. We will move on very quickly about this topic at this part. And actually, this new concept significantly enhances airspace protection by replacing the traditional one-size-fits-all model with the more dynamic airspace and procedure-driven framework. And also old OES concepts based on worst-case assumptions, but new concepts actually based on more real operations and needs actually. And this provides more clear guidance for need of analytical studies by distinguish obstacle requirements based on how obstacle impact flight pursuit operations. Because now we can see which obstacle that penetrates these surfaces. We can make some assumptions and clear overview about these obstacles can be affected, which operations and which procedures, etc. And also, with these new concepts, mobile obstacle limitations on especially runway and movement area, around the movement area in airport, is more clear now. You can see in Annex 14 these changes. And now I will show basic example about the differences between old obstacle limitation surface and the new concepts. And the most efficient way and most clear way to understand the new changes. And now I will show you the example from Esenboğa Airport in Ankara. And I will show you the obstacles and objects that penetrate old obstacle limitation surfaces and new obstacle limitation surfaces. This is so basic analysis, actually, I know, but a more clear understanding about how change of the dimensions of the new surfaces, volume of the new surfaces, you can imagine maybe with more clear with this way. Here you can see the old and current obstacle limitation surface analysis. We can say both old and current because it's there's still time until 2030. After 2030 will be applicable for completely applicable for new concepts. Here you can see the approach transition, takeoff climb surface in horizontal conical surface, obstacle free zones. Here, the obstacle assessment with current obstacle limitation surface. You can see here 3,462 obstacles detected, and we don't know actually how many of them have a risk on operations. It's not certain, of course. We should have a specific obstacle assessments and analytical study. Actually, it shows us it's too protective. And these are the new obstacles limitations concepts on us. Of course, according to each surface, you should make analysis separately, but you can see here how it's changed. 960 obstacles detected after new surfaces, and each penetration has risks, as we know, and need an analytical study. Actually, almost there is a dramatically decrease with the obstacles because old OES concept is more protective. We can say that with these basic calculations. And now these new surfaces, their slopes volume is higher, and also the size is narrower and more compact. It brings the dramatically decrease especially obstacle detecting. Also, on the other hand, I am also the urban planner, you know, I should think about in terms of the municipality, and also it provides us more, for urban planners, more area about especially the increase buildings in or cities vertical increase, because you know, now is the areas, city area sorry, I couldn't. Yes, I remember. The vertical urbanization is now a new trend because it's the most efficient way, according to my opinion, and especially around the airports now. Airports is more closer than the even of the past, more closer than to the urban cities, and we have to be bring this both operation safety needs and airport needs and aircraft needs, operation needs, and also the urban planners needs together. New surface has finally provide urban planners and the municipalities more space actually in terms of vertically, we can say. Here you can see the table. There's a table in here which is comparison of current obstacle limitation concept and also the new obstacle limitation surface and penetration level of same objects. This table is basic calculation again, and the aim of this table I put is to provide you more clear understanding about the change of volume of new concepts surfaces actually. You can see penetration levels changing. Okay. Until now, most of the theoretical part is completed. Now we will move on with the case study, which we talked during the webinar presentation parts. We will move on now with the case study with Esambo International Airport, Mombasa International Airport from Kenya, Wire Airport from again Kenya. Also we have Qatar examples, but I'm not sure the time will be enough to Qatar. Okay, let's move on with the case study to understand more clearly the changes in 3D format. Esambo Airport is located in Ankara, maybe one of them are known, and has 2 main runways, and third is also constructed but not open yet. And on this case, for the Esambo case, according to the aircraft types and the parameters, ADG4 is chosen and runway has category Cat2 and Cat3 precision approach category, and all surfaces already designed because we want to see the changes, but I had to change I had to decide some of the one of ADG, and all surface designed according to ADG4 category. And also for Kenya, 2 airports were selected, Mombasa and Wire. Mombasa was prepared as an again ADG4 airport with a Cat1 approach, and Wire, although normally non-precision, but and also the for the understand how runway code and new ADG parameters change the surfaces. I will make some assumptions, and this Wire treated as a precision instrument approach in this example to show, as I said before, how aerodrome categories may change under new standards. And also this taken into the ADG taken into the account as 2B. Yes, 2B. And here you can see from Esambo, we will see these examples in Google Earth after some few slides. Here you can see in left picture, you can see new approach and transition surface. Blue one is new approach, and red one new transition surface. Green one old transition, and the yellow one is old approach. You can see Actually, this size is more compact now, and also the height, slope height is increased. And here you can see the comparison of in different angles, right? In right picture, you can see the comparison of transition surface change with different angle. Here you can see the size is lower, and also the I know it's understanding from picture is not good, but we will see in Google in a few minutes actually. Oh, sorry, I was not. Oh, sorry, yeah. I lost my mouse and find it good. Okay, here you can see the inner approach, backlanding and inner transition surface changing according to old and new concepts. And with new concepts, inner approach length is increased, and that's why also both transition surface increase. And but you can understand in here how it's change. And also, you can see ADG4 and ADG2B takeoff climb surface. In old concept, takeoff climb surface is standards for each runway, but with new surface, especially for ADG4, it is still slope is same, but ADG2B, the slope is increased actually to 4, sometimes the 5. One is 5, as I said. Here you can see the difference between ADG2B and 4. ADG4 has a 2% slope, but the 2B has a 4% slope. Okay, until now, we will summarize the theoretical concepts of changing. Hope this explanations brings you the more clear view about what is change, how it differentiate from old concepts. And of course, it's not enough to learn or understand all of these surfaces in a detailed way, but with now we will move on with the Google Earth drawings of the new surfaces and old surfaces comparisons. Maybe it can provide more clear understanding. We can say in conclusion, new concepts ensure consistency with aircraft performance and size, and also maintain an obstacle-free area in critical zones around the runway, and also it enhances safety of approach operations by strictly limiting the obstacles. And new concepts also based on approach procedures and missed operations. We can summarize these conclusions and the pros of new concepts actually. Okay, now we can move on with Google Earth. Yes. And actually, we ask you some questions in survey, webinar survey, actually application, webinar registration questions. And there was some questions about 30 questions that will exist. Hope while explaining the presentation, most of the questions, as I see here, would be answered. But if you have a still question, you can write. And also the due to the time restriction, if there's no chance to answer some of the these questions, and we will send the answers via email. And one of these questions about is there any modern equipment available for this OS and OFS? Yes, actually here we create a surface, and during the creating this surface, there is a QGIS plugin which we created QGIS plugin to design and create these surfaces, but maybe some of them aware of there is a software which we published as a Haritaevi. My colleagues maybe sent a software link from the chat, and we will integrate this new surfaces design parameters and designs in an automatic way with this our obstacle analysis software. Please stay tuned and follow this software if you need any software to create these surfaces. But now all these surfaces were created by using QGIS plugin. Okay. Sorry, maybe it can be a little slow due to the sometimes while sharing the screen there was a problem with Google Earth. You can see here both one is Kenya Airport, HKMO, OES surfaces. This is the old one, Annex 14 standard surfaces. And you will see, sorry, you will see OS surfaces and OFS surfaces. Let's check how it's changed. First, start with approach surface as you wish and transitional surface. I will close. Oops, sorry. Yes. Okay, then. I hope this provides you the more understanding. Let's see. We will open one. We will go. Maybe I can change the color of this. Sometimes I don't know. Sorry for waiting. Yes. Okay, here you can see approach size is decreased actually. And also the length of inner edge, maybe you can't understand. Length of inner edge is narrower now. And also the slope is slope is increased. I'm not sure it's clear. Why? Let's see. Maybe you can check. Here you can see the slope is higher now. And also the inner edge length is decreased, and also again divergence difference. Here you can see the transition. Changing. Mr. Halil, maybe you can answer me. Is it clear or too much? There is a too much slow while changing the dimension? Is there?
Maybe you can wait a bit after change dimension before explaining.
Okay, thank you. We can wait a little. You can see this is the airport, which category aeroplane design group is for. Actually, there's two different airport in here. These both airport in old obstacle limitation surface belong to the same category, runway category. Belongs to the same runway category 4. But with new surfaces, one of is now comes with ADG4 and others comes with ADG2B. Actually, this is completely different surfaces. Yeah, not completely, but mostly different surfaces. We can understand in here according to now different size, different dimensions, and different volumes introduced according to each airport characteristics. And let's move on with, for example, maybe transition of the inner horizontal. Maybe I can write concrete. Oh, this is the ground to ground, I think. You can see the horizontal surface changing actually. There is a great expansion in radius and also the height of the inner horizontal surfaces change. Maybe while we're looking at the horizontal surface, height changes I can show in here from assembly. Good. Again, in here you can see the horizontal surface differences. Green one belongs to the ADG2B and the yellow, yellow one belongs to ADG4. You can see the differences in terms of their radius, and also you can see the differences in terms of their heights. It's a little here, but I can show you there is a tower in here. This is new ATC tower, and this is the new runway in Istanbul. This is one of our projects. That's why I want to show this. And here you can see, yes, non-instrument 2B. Okay, you can see the non-instrument 2B. The size of the inner horizontal is 60, yes. Maybe you can understand blue one is the surface and the height of the horizontal surface is 60, and you can see the penetration of this. And this is the for ADG 4. And you can see the height of this surface is 90 meters. As you can see, penetration, there is still penetration, but the penetration is decreased also. Hope this provides you the more clear understanding about the change of the horizontal surfaces. And it is not same as for all airports again, you can see. All right, then. Let's move on with some other surfaces, like new surfaces. See, before start to show new surfaces, you can see the horizontal surfaces still more expanded from conic and in horizontal surface. Okay. Let's move on with instrument departure surface. This is another surface. You can see here instrument departure surface introduced new. See this I will. This is the new surface, much more text, and I will move on with this. Open from 21 and let's open from yes. This is another precision surface newly introduced, precision approach surface. You can see the transition surface and also the then with the new yes. I will wait a few minutes because there is some frozen in this. Okay. Yes, you can see the approach and missed approach, and also as well as the transition surface, which introduced as a precision approach surfaces, and which take category in obstacle relation surface. Actually, there is no comparison with OES for this surface. Here we can compare the change of the takeoff climb surface, maybe. Or takeoff climb surface. Yes. Let's change these colors, but sometimes Google Maps. Here you can see slope is same for ADG for 2 degrees slope, but we will see in the another example slope is higher for ADG 2B. Slope is same, but as I said during the presentation, the length decreased to 10 kilometers, and also the maybe we can say this. With takeoff inner edge also change, except ADG 4 and 5 is still same, but the other below categories, ADG 4 is change and decreased actually. And length is decreased, final white is fixed. Also the divergence is decreased. Divergence of current obstacle limitation surface is 15%, but now is 12.5%. Yes. Here you can see the same slope, but surface is much more like now. Takeoff flight pattern, maybe more closer to takeoff flight pattern now. But I want to show you the differences between the ADG-2B now. And as I said before, these two airports from Kenya example has new aerodrome category, runway category, and their surfaces is exactly the same. For example, takeoff is designed in terms of same parameters, approach is designed in terms of same parameters, but now with new surfaces, we can show with takeoff flight pattern, takeoff climb surface, we can understand clearly how the new ADG group changed the surfaces according to their. Maybe, yeah. Let's go to this one. We will check the approach also. Yes, here you can see again the also, this is the category ADG-2B. You can see the green one is near takeoff climb surface parameters. The slope is increased 4, and also the length is decreased. You can understand the actual differences here more clearly, I think. You can see. And also we can check approach changes with different category maybe. Yeah. Here we can see length of the inner edge is for 2B is 125 meters, but on the other hand 4 is 185 meters. And slope is same actually, and also the slope is increased. You can understand this here maybe more closely. takeoff slope, approach slope is increased. Also, the approach surface length is decreased, and size is more compact now, actually. Yes. Here we can see the park landing, inner approach, and transition surfaces. Maybe you can see this is the newly introduced surfaces again. And we can see, so here, inner approach. Okay, yes. Okay, good. Now it's more to understand the changing of OFS, OFC, obstacle free zone, how now introduced differently with new concepts. We can see here the both landing, inner approach and inner transitions surfaces, and I will show you the increasing of inner edge. Maybe I can I think to this mostly same here. Yes. All right, let's move on with another example, final example. Which surface we couldn't check? I could, yes. This is the one of the other new surface actually, state and approach surface. You can see here state and approach surface is, yeah. This surface also newly introduced. You can see the lower part is much more like inner horizontal, and the upper part is much more like FAA standards actually. These surfaces introduced to protect the procedures in a more efficient way. Here we can say that, sorry, again, yeah, good here. We will find. Very close. Here, the yellow part has higher elevation and higher height, and the inner part is 45 to different sizes. And I can, yeah, okay, so yes, lower section has 45 meter size, and the upper section has 60 meter size. Maybe the understanding is not easy from this part. And also, the parameters for this, again, these surfaces, like instrument departure surfaces and surface for stating instrument approaches, has same parameters, design parameters for both ADG categories, actually, from 1 to the 5. So, much more like approach and the takeoff, and also the inner approach bulk landing surfaces. These surfaces change according to ADG category, but these surface straighten instrument approach, departure approach remains same standards, and also the horizontal surface is changed. Okay, unfortunately, time is run out. We have 15 minutes to check your question. Also, I want to check your questions. As a summary, actually, these are surfaces that introduced newly with new concepts. Maybe some of them similar some these surfaces from concepts studies, but some of them mostly meet new and have no idea about the surfaces. I hope this session will provide you the clear understanding how to change the surfaces from current and the new obstacle limitation surface, and how the parameters and size of the surfaces change. Let me check the question now. Maybe. Yes. Sorry, to facilitate slides, there was a comment. I know the time is very restricted. Sorry for that. Okay, one of the question is very low. What will be the distance of obstacle-free surface from threshold, and categorizing all transition surfaces part of obstacle-free surface would be complicated except in area of overlapping with a flush surface, but for area of overlapping in inner horizontal would be challenging. All right. Yes, this question, there actually, what can I explain it? I'm not sure actually. And the distance from the obstacle-free surface 60 meters, still same for both ADG, and also the now it is not for the transitional surface. There is no situation like old obstacle limitation surface, transition surface reaching up to the inner horizontal. Now it is not the case. Transition surface has actually the different height levels. Yeah, how can I, maybe I can check my, I couldn't remember, but the transition surface now has a height level which can we reach until now. Yeah, now there's no, and also you said that obstacle-free surface will be completed. Maybe we can ask the question more clearly. Sorry, I couldn't understand about overlapping with a flush surface, but area for overlapping with inner horizontal would be challenging. You can make a little bit clarification about this. Yes, materials will be made available after training. If you want to see materials, please send us an email.
By the way, I want to remind that please write your questions to question and answer section. It's not easy to follow all questions in the chat box, so it's better for us to follow them in the question and answer section. And some of them are already answered in that section. If you write there, it's better for us to follow.
I couldn't see that, by the way, question and answer section.
You couldn't see?
Yeah.
You should see in the below maybe some other tab.
Maybe I can check this. Yeah, yeah, good. I saw it.
Right.
Okay, finally, Mr. Damir has a question in chat. Who is leading in Turkey that I'm the study group for Air Force? Do that group integrate Civil Aviation Authority and Spirit Operative. Civil Aviation Authority is leading in Turkey, and also there is a sorry, I couldn't remember.
ANSP.
ANSP, they're working together and leading together. And the process is in our country, analytical study conducted, but the ANSP and Civil Aviation Authority has some rules and standards and legislations, and after the conducted the analytical study, they had to approve these results. And final approval still remains with Civil Aviation Authority. Do you have problems with illegal construction projects are affecting your surface in your country? Of course, we have problems. For example, in Esenboğa, there was too many illegal construction projects, which is affecting surfaces and also the operations, and need to change in case of the minimums because they were illegal and already constructed in Turkey. It is hard to demolish already constructed building actually.
Mr. Can you change your screen so maybe people can see the email address? Some of them are asking for email address.
Okay,
Yeah.
you can send Haritaevi or errol@haritaevi.com. Okay, let's move on with the webinar questions. And in both webinar chat has some questions. I will send all the answers with email because there was some questions that I couldn't catch. Which software do you use when creating OES softwares? Actually, we are using, as I mentioned during the webinar, using obstacle analyze software, which we created in-house, and also the publish. And for the new concepts, we created a QGIS plugin. Actually, I created a QGIS plugin, and we will integrate this new surface parameters into the obstacle analyze surface.
Yes, you can find the obstacle analyze website in the chat box. Our colleague sent the information about the obstacle analyze. And maybe I can say that some of the civil aviation authorities in the world are using this obstacle analyze software. One of them is Kenya Civil Aviation Authority. And we will make available this new OLS function, new concept for them priorly.
All right, another question. If the airport get to ADG to C, do we need to take the higher criteria as airport being used by the highest aircraft category? And yes, I think is it possible to use higher criteria, or the most demanding aircraft category criteria is better? Actually, most demanding is better now. How is the approach surface different in terms of the dimensions of new set in relation with the OES system? Approach surface is also change with new concepts, as I I think I answered this question, but again, I will answer that. Approach surface is change according to length of the inner range, and their slope is increased to 3% around. And it is totally different. Now is the divergence is narrower and also the length is less. It is actually not same with the current OLS system. I think the question is this. Yes, Mr. Dlamir, some of the questions that I answered. Let's move on to what software is used for these studies. Do we have more software for integrate? As I said before, QGIS plugin is used for now. Of course, obstacle analyze software is these new design surfaces will be created to obstacle analyze surface. I think we could change. Okay. Do we need to know the ADG for each aircraft operating each AD to create OES-OFS specificator? Yes, you should know the ADG and to create OS. Actually, to create OS, no need, because not of the because, for example, takeoff flight criteria and the precision approach, missed approach, transition and approach surfaces are you need to know, but for the horizontal surface in OS instrument, you need to know again ADG, and instrument departure surface and straighten instrument approach surface, you don't need to know AGD. Of course, some of these OS surfaces can be not applicable for your airports. It is actually for example, as I said before, horizontal is not applicable, circling is not, or your airport didn't has any don't have any precision approach, then you don't need to know, etc. Or the airport runway is only the takeoff runway, but still you need the ADG. I can summarize that ADG you do not need dimensions for instrument departure surface and instrument approach surface because it's all the same parameters, but the other all surface you need to decide ADG. Okay, what is the process for conducting? When OS is penetrated or with new study, any object that penetrates of the OFS or OES should be conducted with aeronautical study and should be must be the risk assessment study, and the risk assessment study results should be the approvable by the authority. What new tools and training are required for our staffs? We can have, but you can create these new actual parameters are published in ICAO, and you can use these parameters and create surfaces in JS environment, maybe the CAT environment. In 3D, you can create 3D surfaces and then create maps. Usually the creating maps and this 3D analysis, JS environment is better options. We can use ArcGIS. As I know, ArcGIS also published the new surfaces parameters and the design package. Yeah, in aviation mode. But of course, you can follow our obstacle analysis software. And we can send you the web link. Yes, Mr. Halil, can you send the web link again? And how to choose criteria if airport being used by different type of aircraft category. Actually, if the airport have different runway, each runway should have a unique different ADG, and also you can choose the most critical aircraft or the most used aircraft during the departure and arrivals. In practical terms, how new OS and OS framework affect coordination between the aerodrome operator and SP regarding obstacle assessment? Actually, I'm not sure because this depends on which country you are and how your legislations and authorities are actually the parties involved your study. Maybe I cannot say exact answer. And there's no one answer for this. It can be changed according to us. Please, can you tell us when this software obstacle analysis will be available, cost, and if there is a more in-depth training on its use? Of course, there will be a cost. I'm not sure, maybe, but we have a agreement with Kenya Civil Aviation Authority. We will integrate the new surfaces into their system already, but there will be a cost, and there will be the deep training. If you wish, you can send email. Because the time is really restricted for such webinar. This webinar is only prepared for general informations and the general awareness about the new concepts. When this change going to be adopted in Nigeria, whenever you want, you can adopt this to Nigeria. This is already published, and there is a ICAO set time until 2030, but you can adopt if you wish. You can send email for the detail. As I said, 2030, yes, final date for the new adaptations, new surface adaptations. Okay, we can give the criteria factors that we need to identify new OES, to establish new OES, you should first understand the new concepts. You can take trainings, you can evaluate the new Annex 14 publications, and also first, you should create with your civil aviation authority, especially if you are civil aviation authority, should be make some implementations and regulations to implement new obstacle limitation surface. And is same as the ICAO Annex 100 obstacle OES, old OES, there's some recommendations that ICAO conducted. For example, in Turkey, some of these recommendations are applicable for Turkey, or some of them not. Some of them in while ICAO put the recommendations, the others puts in Turkey puts as a mandatory. So first, civil aviation authority must be prepare a ground for the new obstacle limitation surface, establishing and prepare rules and the regulations, and then you can, of course, implement your systems studies, etc. Thank you. We will check your email. Again, the Annex 14 was published in August, and all these changes will be completely effective in 2030. And how long does on-the-job training for obstacle evaluator assessment taken Turkey? It's actually can be changed about the insight or content of the training. If its content is more deeply like with workshop or training, or only the theoretical training, it will be changed actually according to your request. Yes, Mr. Ayul.
Okay.
I think we come to the end of our time. Sorry if there's any question that I couldn't answer, or actually the all questions I will send answer again via email, because some of them can be I couldn't catch, and some of them can be couldn't read properly with others. Maybe we can send all the people answers with email, and you can see them. Okay, then I will shut down this. Thank you for your time. Actually, hope this webinar will be the efficient and the more practical for you to understand the new changes, and also obstacle limitation surface and the current, to understand differences between old and the current one, and also to understand the design parameters and changing and the differences, and also the its aims, why this change, and what this change brings to aeronautical studies. Hope all these questions get answers, and the session will be the most productive for you too. Thank you for listening. We can come to the end of the time.
Thank you.
Say thank you and goodbye. You can send email always. If you have any question or any information in detail, we can prepare meeting and other things or questions. Okay then.
And thank you all of you for your time and engagement with the questions. Before you go, I want to remind that if you are from Civil Aviation Authority, ANSP, or an airport authority, please send us an email. We would love to set up a private workshop with you to prepare you for this transition. And finally, as you leave, a short survey will pop up, and please fill it out if you can. It will really help us to make these webinars better. From all the team at Haritaevi Aviation, thank you for being here today. Have a great rest of your day. Bye.
Have a great day. Bye. Maybe we can, okay. Did we publish the survey, Rally?
Yes, when they leave, survey will pop up. Okay, bye.
Mhm.